All right, hi, Algebra 2, we are back. Moving on to lesson 1.5, and we're going to solve equations and inequalities by graphing. We'll learn how to do it other ways soon, but right now we're just going to graph. So remembering those parent functions is going to become really helpful. So the first example is to solve negative 3x plus 20 equals 5 by graphing. Basically, what does x have to be? Some of you may already know how to manipulate the equation to find x, but how can we do it by graphing? Okay, so if we want to do it by graphing, let's just set up a graph over here. Just set it up over here so we can use it. All right, so the first thing I'm going to do is I'm going to break this up into two equations. I'm going to break this up into y equals negative 3x plus 20, and then I'm going to break up the other side to y equals 5. All right, so hopefully this one is becoming easy to graph. So y equals 5. I'm just going to, let's see, break up. Let's do this. It's 5, 10, 15, 20. So y equals 5 is a constant line. Here it is. This is the pink one. Y equals 5. Easy to graph, right? Okay, next is, get another color. Next is y equals negative 3x plus 20. Now hopefully you see why I went to 20, because this is slope-intercept form, right? The y-intercept is at 20, so I can put a dot there. And the slope is negative 3, right? So this thing is going down. So I'm going to go about down 3. I'm going to make this, since this is, now I have to, let me be consistent here. Let me make this. Actually, I'm just going to do this. I'm not going to be consistent. So we can actually see it. And so if I go down 3 over 1, we're somewhere like here. Down 3 over 1, we're somewhere like here, right? So I'm just estimating what that would look like. And let's see. If I keep going, it's going to be something like that. There's that first linear equation. Okay, so what is the solution to this? Well, the solution is where it intersects, right? So it intersects right here at x equals 5. So the solution is x equals 5. So let's plug it back in and check. Negative 3 times 5 is 15, negative 15, and negative 15 plus 20 is positive 5. Yep, both sides are equal to 5. So that is the correct solution. So what you are seeing out of this is that if you have to find the solution to two equations, the answer is where those two functions intersect, those two equations intersect, right? Okay, so there's an easy example with just lines. Okay, here's another example. Now we have to solve it with absolute value. Solve the absolute value of x minus 4 equals 1/2 x plus 1 by graphing. By the sun, I see a shadow here. Okay, so we're going to graph. So I'm just going to stick with the positive quadrant again, because I already know they're going to be there. If you didn't, you could spread it out, right? So we're going to set up two equations. One that says y is the absolute value of x minus 4, and one that says y equals 1/2 x plus 1. Okay, I'm going to graph the second one first because it's slope-intercept form. That seems easier to me at the current moment. So y equals 1/2 x plus 1. So let's just have, let's see what I want my scale to be. We'll go by 2s. 2, 4, 6, 8, 10. All right, I'll go by 2s here. 2, 4, 6, 8, 10. Okay, so for my second one, my line, my y-intercept is at 1, so here. And my slope is 1/2, so that's up 1 over 2. Up 1 over 2. Up 1 over 2. Up 1 over 2. So you can start to see how that line is going to cross right there. So let's just go ahead and extend it. Draw that. I'm trying to scooch under the iPad to do it, so it may not be perfect. There it is. Okay. Now let's do the other one, absolute value of x minus 4. So this is why your transformations came in handy, because the absolute value function, remember, is that v, and that v happens at 0, 0. Okay, but I see this minus 4 here. That minus 4 is a horizontal translation. That means that vertex is moving over to the right 4. So instead of the vertex being here, my vertex is at 4. Right? And then everything else, just going up, is the same. So let me get my four, and then at 3, it should be 2, it should be 2, 4, it should be 4. Here we go. Okay, so I'm just connecting it up. Should be crossing those grid lines here. So going right up those center grids. Remember, if you get completely stuck, you can always make a table. So like if you wanted to, you could have went x with an absolute value of x minus 4 and actually figure those out. And you would have plugged in 4 and you would have known it's 0. And you could have plugged in 6 and you would have known it's 2, right? 6, 2. So I just kind of did that from my pattern of knowing that graph, but you can always make a table to figure out where those points are. Okay, so where are my answers to this equation? Well, where do they intersect? Intersects here at x equals 10, and it intersects here at x equals 2. So my drawings aren't perfect, but I can tell that they're supposed to intersect there. So there's two answers to this, x equals 2 and x equals 10. And if I plug them both in here, I can see that they work. Let's just try 2. 2 minus 4 is negative 2. The absolute value of negative 2 is 2. Okay, does this side equal 2? 1/2 of 2 is 1. 1 plus 1 is 2. Yep, that works. Same when I plug in 10. This side is 6, and this side is also 6. So those two both work. That's where they intersect. Okay, that's how you solve them when it's an equation. What about when it's an inequality? So this one, x squared minus 4 has to be greater than 0. X squared minus 4 has to be greater than 0. So we're going to graph. This time I'm going to include all 4 quadrants because I know I have a parabola. If it was x squared, the vertex would be at 0, 0. But it's x squared minus 4. It's a vertical translation down of 4. Right? So here's the vertex. And then it's going up. So let's just pick some other values. What if I plugged in, let's plug in 2. If I plug in 2 to x squared minus 4, I would have 2 squared minus 4. That would be 0. So at 2, it's 0, which also means at negative 2, it's going to be 0. So that's enough for me right now. That's all I'm going to need. Okay. So there's my sketch of what that graph will look like, and now I need to figure out where it's greater than 0. Well, it's greater than 0 everywhere up here, right? Everything above the x-axis. So what are the intervals? There's 2 parts of this function that are in that part, this left extension and this right extension. So how would we write this? Well, we're going to write it in interval notation, right? So this thing is greater than 0 from negative infinity to negative 2, but it's not including negative 2 because that's when it turns to 0, right? And 2 to positive infinity. Those are the 2 intervals where that thing is greater than 0, right? Okay. Let's try one more. Use a graph to solve x squared minus 4x plus 1 equals x minus 2. So we're going to do those same things. We're going to have 2 equations. We're going to have this, and we're going to have this. Let's make a graph. All right. I'm going to graph x minus 2 first because that's a lot easier to graph. Let's use my green. We'll just go by ones. Let's just go by ones. So I'm not going to even mark it because these are all ones. Okay, so Y-intercept is -2. It's here. My slope is +1, up 1 over 1, up 1 over 1, up 1 over 1. That is making this line very easy to sketch because it's going to cross all my little intersections there. Let's see. Hope that's good enough. Okay, there's this one. There's my line. Okay, now we have to graph this parabola. Okay, that's going to be a little trickier, right? Because it's not just x squared. It's got all of these things on it. So let's just make a table. Just to make our lives simpler. Let's make x, and let's make this thing x squared minus 4x plus 1. All right. If I plug in x equals 0, I get 0 squared minus 0 plus 1. Okay, so at 0, we're at 1. What if I plug in -2? Should have maybe started with that. So -2, that's going to be, let's see, that's going to be -2 squared, so that's going to be 4 minus 4 times -2, that's plus 8. Let's do this over here. I don't want to run out of space. So if I plug in -2, I'm going to end up with -2 squared minus 4 minus 2 plus 1. That is 4 plus 8 plus 1. So that is 9, 10, 11, 12, 13. Right? So at -2, it's at 13. Okay, so that's going up there. What about +2? So if I plug in +2, all of this is going to be the same. It's still going to be 4, but it'll be -8 plus 1. So what's 4 minus 8 plus 1? And 4 minus 8 is -4. -4 plus 1 is 3. So at 2, it is at minus, did I do that right? Let's check. 4 minus 8 plus 1 is -4 plus 1. Yeah, -3. I just forgot my negative. So it's -3. Let's start to sketch this and see what we have. So at 0, it's at 1. At -2, it's 1, 2, 3, 4, 5, 6, 7, 8. It's like all the way up here somewhere. I'm just going to draw it. And then at 2, it's at -3. 1, 2, 3. So I can start to see it's like that. But I don't know when it's going to go up yet, right? So is this the vertex or not? Let's try 3. What happens at 3 here? We end up with 3 squared, that's 9, minus 3 times 4 is 12, plus 1. 9 minus 12 is -3, plus 1 is 2. -2. So we can see it's starting to go up. So at 3, it's at -2. So yeah, so somewhere in here, it's going up. And I wonder where it crosses again, right? So I'm just going to leave it right. Like, I know it keeps going, but I'm not sure where it crosses yet, right? Let's see. Let's try 1, 2, 3, 4. Let's try 4. Maybe that's going to get me 0. 4 squared is 16. Minus 4 times 4 is 16 plus 1. So at 4, we're actually up here. So it crosses somewhere between these two, right? It keeps going. Okay? So I just had to make a plot to see what this looks like. So there's my rough sketch parabola, and this one's in blue. I didn't change my ink. Okay, so where's the answer? Where are the solutions? Well, here's one solution. And here's another. Right? Now, these are not as easy to read because they are in between, right? I can estimate, but it's not going to be exact for 2 reasons. One, I sketched this by hand. And 2, these scales are really big. So if I'm going to write my answer, I know one solution is between, where x is between 0 and 1. And then a second solution is in between, what is this? 1, 2, 3, 4, 4 and 5. So when x is between 4 and 5. right? So I'm going to leave that. I know that I have two answers there. This would be really helpful for multiple choice because I can narrow it down, right? And then I'm going to show you the cool way you can do it on your calculator. You could also do this on Desmos if you don't have a calculator, by just typing in these two functions, and then you scroll your mouse over where they intersect and it'll tell you what the value is. But let's go ahead and do them in our calculator if you have one. So let's put x squared minus 4x plus 1. This is my blue graph, and then x minus 2 is going to be my red graph. Let's see if we can see it. There they are, much neater than what I did, right? Let me see if I can get it zoomed in more. I hit zoom 6. So now I can figure out where they actually cross. I can trace, right? But here's what you can do. If you do second calc, 5 is intersect, so I hit 5. It says first curve. Okay, I'm going to hit my first curve is this blue one. Second curve, it says hit something on the red one. There we go. And then it says guess. Yeah, I want you to guess. So the intersection for that first one is 0.697. So we actually figured out that this thing is 0.697, which is in between 0 and 1. So that's correct. All right? And then we can do it again to find the x value there. So I'm just going to go to second calc. I want to do another intersect. It says to guess on the first curve, so I'm going to go closer to the second intersection there. Guess on the second curve, that works out. Do I want you to guess? Yes. There we are. My intersection here is x equals 4.302, right? Continuing on 7756. And that is in between 4 and 5. So if you have a calculator, you can check that. And this is what you would do in the real world, right? We just have to know the math behind it, and this is how we got there. You can also try it in Desmos. All right, see you guys next time.